Okay, so this is part 3 of the chemistry refresher series, and we are going to look at reaction stoichiometry in our chemical reaction and begin to solve this problem. So what we need to do is look at reaction stoichiometry so that we can identify what our limiting reactant is. This is our balanced chemical reaction here in R, and in our previous video we found our initial amounts of our reactants, and so now what is our limiting reactant, because that is going to determine C here, our change. So if we look at our reaction stoichiometry, that is determined by the coefficients in front of our reactants. We have 1 to 1 to 1 to 1. So our reactants react in a 1-to-1 ratio to form two products in a 1-to-1 ratio. So our limiting reactant is going to be the one that we have the fewest moles of. So first, actually, let's define what a limiting reactant is. The limiting reactant, this governs the theoretical yield of product in a reaction. Okay, so what does this mean? Well, basically, you can't make more product than you have reactant available to you. So let's look at how this will play out in this reaction, and it might make it a little bit more clear. So, like we found earlier, these react in a 1-to-1 ratio. Our limiting reactant will be the one we have the fewest moles of, which, based on our initial amounts, is lithium hydroxide. So this is our limiting reactant. So our change then, in a reaction, the limiting reactant is always consumed. It's fully consumed, so our change will be the subtraction of the amount of our limiting reactant from our reactant side and adding this to our product side. Okay, and so at the end of the reaction, or at equilibrium, we have none of our limiting reactant left, and of HBr we will have some left over, and that's okay if that happens. It's just going to hang out there in the reaction vessel, and we will have 0.02 moles of water and lithium bromide formed. Okay, so this is the theoretical yield of our reaction, the maximum amount of product that could be formed based on the amount of lithium hydroxide and hydrobromic acid in the reaction to start with. So this is our theoretical yield. 0.020 moles of lithium bromide. If we wanted to find the molarity of this, we would just put our moles over liters, the volume of our reaction, which is 50 milliliters or 0.05 liters. And this comes out to be 0.40 molar lithium bromide. Okay, and so that is the answer to part A. In part 4, we will answer part B of this problem, and we will also learn about percent yield.